In this quick video, I'll show you how to use the Average Nearest Neighbor tool in ArcGIS Pro to find out whether your point data is clustered, random, or dispersed. I will be using Ukraine conflict dataset to see how events are distributed across space and why that matters before moving on to more advanced spatial analysis. Before doing anything else, I need to make sure the data layer is projected. I'll go to the Contents pane, right-click in the layer and choose Properties, Source, and Spatial Reference. If the coordinate system is in degrees like WGS84, I will need to reproject it to a projected coordinate system that uses meters. However, in this case, the layer is already projected and it is using meters indeed. This is crucial because the Average Nearest Neighbor tool measures distances. I will go to the Analysis tab, then I will click Tools to open the Geoprocessing pane. And in the search bar, I will type Average Nearest Neighbor and open the tool from the list. In the tool window, I will set the input feature class and select the Ukraine conflicts point data. I will leave most settings as default, click on Generate Report, and most importantly, include the area of analysis. In this case, I will get that number from the Ukraine country boundary. And then I will click Run. Once it finishes, I will check the Average Nearest Neighbor summary in the results panel. For this dataset, you can see the results in the report. First, the points are clustered, and it is indicated right here. Because the observed distance is much smaller than the expected distance, and the z-score is extremely low with a p-value near 0, the pattern is highly clustered. Understanding whether this data is clustered, random, or dispersed helps me determine if spatial analysis will actually be meaningful. In this example, the Ukraine conflict events are clearly clustered, meaning there's a strong spatial correlation worth investigating further. Hence, it makes sense for me to continue with tools like the hotspot analysis or the kernel density or spatial autocorrelation to explore why those clusters form. If points were scattered without a clear spatial patterns, then further spatial analysis might not add any value, since there might be no underlying spatial structure to explain. Now, if the points were more evenly spaced than expected, then it would suggest competition or regulation, like evenly distributed facilities or managed location. This is useful to know, but not something I would analyze with clustering methods. So in short, the Average Nearest Neighbor tool is a quick, is essential first step that will help me confirm whether my data has a meaningful spatial pattern before diving deeper into more complex analysis. So I will let you with this, and then we'll continue with the rest of the spatial analysis tools.